Ćao svima, dobrodošli na Practical UX Meetup. Današnji meetup namjerno je najavljen kao skup i dizajnera i developera, and today's meetup will be in English, so we will talk about web performance and how it affects overall UX of the web, especially images, right? Today's our guest is Png Files. Please applause for him. Doug is originally from Seattle. He's coming, basically he is now living in Europe, and he's a performance expert, right? If I'm right. Engineer as well.
Yeah.
Performance engineer, yeah, let's call that. And the format of this talk will be that in the first part, he will give a presentation about performance, and you can always interrupt him with the questions if you need any more explanations. And afterwards, we will have a Q&A session. Welcome, Doug.
Thank you. Thanks for having me. Thanks for putting on the meetup. I really appreciate it. I'm Doug. I was in Dublin this morning, and so by way of Dubrovnik, if that makes sense. That's just the way, right? Whatever. And so, as you said, I've been traveling with my family around Europe for about 4 years, so I'm sort of a digital nomad, but I lived in Seattle for a long time. And so I'm going to talk a little bit about how to speed up the web, mostly just by making images smaller and still look beautiful, because that's important. And I get to share pictures of all the cool places that I've gotten to go. And so this is a castle in West Cork, Ireland. And according to people in Cork, Ireland, the further you are away from Cork, the longer you say the word west. And I was in West Cork. It was like a 3-hour drive. But it's like it's a castle from like the 1100s, which as an American, that's really old. But I know that like, that's only 1,000 years old, and that's not super old here in Europe. But I started doing performance work. I used to work for AT&T in America. I was doing developer relations and helping people speed up their apps and their websites, and I wrote a book on how to do that. And then I asked AT&T if I could travel in Europe for a year, and they said yes. And so I did with my family, and we went back to America, and my wife said, I still want to travel. And so I said, AT&T, can I travel in Europe again? And they said no, so I'm a freelancer. And so I help companies figure out how to speed up their websites, speed up their native apps. I run workshops on performances, video, augmented reality, a little machine learning, all sorts of fun stuff. I'm the only Doug Sillers on the internet, so I'm easy to find if you ever have any questions. And so before we get started, this is called First Cliff Walk, and it's in the Alps. And how many of you get a little nervous thinking about like walking on this walkway that's literally nailed to the side of an Alp? Right? I mean, and so we walked across this, and it's a little terrifying, and my daughter was 6 at the time, and she jumped, and so it rattled as we were walking across it the whole time, which added a little to the experience. But a few years ago, Ericsson did a study, and in this study, they put sensors on people's heads to measure stress responses to different things, and they found that queuing in line, thinking about queuing in line, raised your stress a little bit. And thinking about walking on the edge of a cliff really raised your stress level, but they actually found that a slow mobile website is more stressful than standing on the edge of a cliff. And so like that nervous feeling you all had a minute ago just thinking about walking on, the edge of a cliff, if the website you're working on or the app you're working on is slow, your customers are feeling frustrated. And if it's an e-commerce site, like if you think about going to the mall, it's always really bright lights and it's always happy music, because if you're feeling happy, you spend more money, right? That's the whole goal. But if your website is slow and your customers are already frustrated, people don't spend as much money. So it's really important that we actually have fast websites. There's a lot of data here. Google found that a 3-second delay causes half of your customers to leave the web page on mobile. A half-second delay increases frustration and lowers engagement. Both Amazon and Walmart found that a 100 millisecond delay causes a drop in revenue. And just 100 milliseconds, I mean, that's nothing. And then, of course, a few years ago, there was a study, and 4% of mobile users admit to throwing their phones when there's a slow mobile website. So like these are things we don't want to have because, you know, cracked screens are bad. And also we want to make sure that people are staying on our web pages, because if they leave in a frustrated way, they're less likely to come back again in the future. And if you start looking at how web pages are built, right? We've got JavaScript, we've got CSS. This is 10,000 web pages from April. And if you look, just about all of these web pages have 50% images, right? So if 50% of the stuff being downloaded are images, what if we can make the images smaller? We can get the web page to download faster. So that's what we're going to do today. We're going to walk through ways to make images smaller, because if the images are smaller, we're going to have less kilobytes, it's going to download faster, and our customers will be happy. Has anyone used Lighthouse or know of Lighthouse? A few hands. All right, so Lighthouse is a tool built by Google. It's inside Chrome DevTools. It's inside a tool called Webpage Test, which I'll talk about. And it basically gives you a bunch of techniques on how to speed up your web page, specifically towards mobile. But if you speed up your web page for mobile, it's going to be faster on the desktop too. And there's 4 optimizations that are in Lighthouse. There's image quality, image format, image sizing, and lazy loading. And we'll talk about those. So has anyone here used Webpage Test? Yes. A couple hands. Again, one of my favorite tools of all time. So it's a web page. You can test your website all around they have instances of Webpage Test running all around the world. So you can see how fast your web page loads in San Francisco, in Virginia, in Amsterdam, in Singapore, right? It's running everywhere, so you can see how fast your web page loads all around the world, and it gives you lots of performance insights. It runs Lighthouse, so you can test the Lighthouse score all around the world. There's another tool called the HTTP Archive, and what this tool does is every month it runs web page test on 5 million web pages, and then throws all of the data into a database that you can then query and learn about how the web is being built. And since there's 4 optimizations that run in Lighthouse, I can get that across 5 million web pages, and we can learn how the web is being built today. So let's focus on the first one, which is image quality. And so the Lighthouse recommendation is saving your images at 85% quality. So, you know, if you open up an image in Photoshop, you can, and you save it, there's that quality bar. And as you lower the bar, the image gets smaller. But if you go too small, the image starts to look bad. So you want to find that sweet spot. Google and the Lighthouse folks found that 85% always gives you a good image, and you'll save usually about half the size of the image from 100%. There's tools like Image Magic, which from the command line where you say save it at quality 85 and it spits out the quality 85 image. They're cloud-based tools like Cloudinary. You upload a full-size image and they give you a URL, and then you just put this term right in the middle, and on the fly it'll generate a quality 85 image for you. And so what that looks like is, this is in Riga. The original image was 3.6 megabytes. When I save it at 85%, it's half the size. And there's no visual change to the human eye that the image looks any different. So we've made the image half the size. We know it's going to download twice as fast now because it's so much smaller. If we look at how this is being used in the wild, a year ago, 43% of the web was passing and 1/3 was failing. They've changed the scoring a little bit. Now almost 50% of the web is passing, but 1/3 is failing, scoring less than a half. The median page here would be almost 4 seconds faster on mobile and use 133K less data. The folks down here scoring 0 would be almost 10 seconds faster and use 1.6 megabytes less data just by saving the images to 85%. That's a pretty huge savings, and if you can speed up your page 10 seconds, you're going to get a lot happier customers. But what if we go even smaller? So you can see on this projector, 50%, this is a crappy looking image, right? We don't want to go to 50%. That looks really bad. You can see up in the sky, there's lots of kerning. And actually, around the building there, it looks horrible too. Some projectors don't show that very well, so I always have a 20% image too, and that one just looks miserable. So we know that that's okay. We know that's bad, but what if we could probably do better? And there are actually tools that will do that for us. So 85% is what Google says. Like if you do 85%, you're going to be fine. But there's actually tools that will go better than that. One's called Booter-Augli, and the other is Structural Similarity. And what it does is it lowers the quality to where the human eye can see a difference, and then goes a little higher. So if the human eye can't tell a difference, you might as well get it, lower the quality as far as you can to save kilobytes. And so you can do that with this command line tool, which you can get from here. Cloudinary will do it again from the cloud. Instead of Q85, you say Q-Auto. It saves it automatically a lot smaller. And now the image is 1.46 megabytes. So we've saved 400K just by doing the structural similarity. And the image still looks great. Actually, we see a little kerning here, but the image still looks great on a desktop. Like, this is a really big screen. So, we save 400K. So this is what web page test looks like. And when I test the full-size image on a 3G connection, it takes 21 seconds to load. And that's obviously way too long. When I go to structural similarity, it's 9.5 seconds. So I've sped it up over twice as fast. It's over twice as small. We're making this a lot faster. The next thing we can look at is the image format. There are a lot of different image formats that are out there. And here are, this is the average web page image size for JPEGs, PNGs, Gifs, WebP, and SVGs. You guys know SVGs? SVG images? All right, great. So SVG images are infinitely scalable. They're XML, because they're just shapes. And so you can stretch them as big as you want, and they always look great. If you see that there's some artifacts here, that's because PowerPoint doesn't support SVGs. And so I had to take a screenshot of the SVG to put it into PowerPoint. They need to support SVGs. That would be really nice. So I found this web page that has this SVG. It's like a bullseye. It's a separator, to separate two sections of the web page. And SVGs are XML. So I was like, let's see what we can learn about this SVG file. And you can see right here, it's drawing the circles, right? These are the circles that it's drawing right here. And then you can see Adobe Illustrator and a whole bunch of stuff. And so when you make an SVG in Illustrator, it saves the JPEG or whatever your source file was as base64 and embeds it into the file. And so this file was 946 kilobytes. And if you ever work with SVGs, that's a little bit large to be putting live on the internet. So the way you fix this is you click right here and you drag to the bottom and you delete it and then you resave the file. And when I did that, it was 1 kilobyte. And then of course it's XML, so I can gzip it or use Brotli to compress it to 0.5 kilobyte. So this web page still has this live. I haven't looked in about 3 weeks, but it's still live. 900 kilobytes for this file, right? That's insane. They also have an orange version. And as you probably know, you can take the red one and you can style it and turn it orange with 2 lines of CSS. You can take the SVG and turn it orange. They went the approach of another 940 kilobytes. So we've got 1.8 megabytes of circles that could be 1 kilobyte or less than 1 kilobyte of data. This sort of goes to like testing, right? Like if you build a web page and you see these giant files, maybe you should go look and figure out why they're so big. In this case, they didn't, and it's still live. So don't do that because that's a huge waste of data and it's going to make your web page really, really slow. PNG files are another thing. PNG is a great image format. It has transparency, so like Gifs and PNGs, you can have a transparent layer, which you can't in JPEG. They're really, really useful. Most of the PNGs that I see on the web today sort of have this format: screenshot, year, month, day, time.png. There are websites out there where they are getting the image perfect on their screen and then using their Mac screenshot tool to take a screenshot and then pushing that live to production. And the screenshot tool is awesome. Like I took a screenshot of my tweet here because it's a great way to do that. And this is from Chrome DevTools. But like, that's not what you want to be pushing live onto the internet, onto your web page, because I went and I found a bunch of images that were doing this. I took 3,000 of them and I wanted to see how much smaller I could make them. And I thought I had another slide here, but just a few months ago, there were 400,000 of these live on the internet. 2% of the web pages in the HTTP archive have screenshots on their web page. So like 2% of the web is doing the wrong thing here, and they're not optimizing these images. So like 2% doesn't seem like a lot, but it is a lot, right? 2% of the web is putting images up on the web like this that could be a lot smaller. Finally, we'll talk a little bit about WebP. WebP is a format that came out of Google, and a year ago it was only in Chrome and in Android. But now you can see it's in Edge, it's in Firefox. Safari has been thinking about it for a really long time. We're hoping that they get it in there. But we've got 3 of the 4 major modern browsers supporting WebP. It might be something to look at. WebP being a newer format, you get better compression than you get in JPEG. If I do that same image, structural similarity, and then I turn it into WebP, it's under 1 megabyte. So I've saved another 400K, right? This image is just going to download faster and faster. And by making it a WebP, it downloads 2.5 seconds faster than the JPEG. As by using the picture tag here, I can serve the WebP. If the browser doesn't know what to do with the WebP, it falls back to the JPEG. And so it'll get the 1.5 megabyte, it'll still load. But for the browsers that can support a WebP, you get the 1 megabyte image, and it loads a lot faster. And then, of course, you should always have an alt tag for people who have screen readers or can't see the images. So if we look like a year ago, only 16% of the web was passing using WebP. It's still pretty low, and 62% are completely failing this. And these pages, the median page, like right about here, that page would be 6.6 seconds faster just by changing the images from JPEGs to WebP. Down here, these websites, 13% of the web could save 2.4 megabytes or more and be 15 seconds faster on mobile. That's huge. I mean, there's a lot of performance possibility here just by changing the images to WebP. Image sizing, this is responsive images. This probably makes a lot of sense to everybody because you serve a different size image to this device than you do to that device, just because the screen sizes are so different. So, Novisod, see? The original image here I took was 13 megapixels. It was 1.6 megabytes. I do all the optimizations we just talked about. It's still 13 megapixels and 800 kilobytes. The problem is, of course, if I get it onto a small device, I'm only using 500,000 pixels, but I'm downloading 13 million pixels. So you have to download all 13 million pixels, and then the CPU has to fire up and throw away 12.5 million pixels before it can show up on the screen. And the best analogy I can come up with this is like when you order something online, and it comes in a box with like 8 meters of brown paper before you find out whatever was in the bottom of the box of whatever you ordered. We're doing this every day with lots and lots of images. The other problem with this is if we do that, and you serve a giant image, and then you only have 1 million pixels on the screen, I ran a test, and on a desktop, on a 3G connection, it takes 14 seconds to download this image. But the desktop can process the image and throw away the 15 million pixels in this case in 78 milliseconds because desktops are fast. The Motorola G4, which is like a mid-range Android device, it takes 200 milliseconds for it to do all of that work. But the Alcatel One X, which is a really, really low-end Android phone, it was released last year. They're really cheap. They're like 60 euros. So they sell a lot of them because these are the phones that when you go into the cell phone store, they've got the Pixel over here, and they get lower and lower and lower, and then there's the one that's not plugged in. That's this phone, because they don't want to see how bad it is. But this phone takes almost a whole second to process the image. So it takes an added second delay to process that image if you don't resize it properly for the device. There are a lot of Android devices out there. This is just Android devices. Each square is a different Android device that hit Akamai in one day. The color is the speed of the processor. So these are all like Samsung new devices. They're fast, awesome processors. A lot of people use them. There are also a lot of people out here using low-end devices with really, really bad processors that are going to have that really slow effect, that 800 millisecond decode time. So what do? We generate a bunch of different images, In this case, I'm generating images that are 25 kilobytes different in size. That way I only ever waste a maximum of 25 kilobytes. And so when I serve it on this tiny little device, now I'm only wasting 100,000 pixels. So it's going to download a lot faster because it's like 95 kilobytes, or maybe it's that one at 120 kilobytes. I'm only wasting 100,000 kilobytes instead of 12 million. There are a lot of tools that'll do that. This is the open source code for it, so you can download this, make this part of your image processing pipeline. They also have a web page that does it. So here I uploaded an image and said, give me a bunch of images between 200 pixels and 1400 pixels, 25 kilobytes apart, and give me 20 of them, and I get a zip file. And I can put those live on my web page. Here's the huge savings, right? Because now it's sized properly for a mobile phone. It only takes 2 seconds to download, and it's only 121 kilobytes. That's going to load a lot faster from the original 3.7 megabyte image. I'm down to 120 kilobytes. That's going to be super fast, and it's going to load really, really nicely for our mobile users. A year ago, yeah?
One question. How do you pass the information, what bucket, what image you want from the... Do you load different URLs, or is it...
So you can use media queries in the picture tag, and I don't have that slide in here anymore. I took it out. But you can actually say, for this width screen, serve this image. For this width screen, serve that image. And so you can actually programmatically tell the browser, and the browser will say, this is Doug on his desktop. His screen is 2,000 pixels wide. I can serve the big image. Oh, this is Doug on his mobile phone. Let's give him the smaller version.
In the HTML.
In the HTML. So it's in the HTML. And so the browser gets all that information, says, I need this one, and then requests that image from the server. And so the proper one is served from the server. There is a thing that used to be in Chrome but got pulled out. It's called client hints. And it's a header that would actually report the size of your screen back to the server. When the request is made, there'd be a header that says the screen is 1080 pixels wide. And then you could immediately serve the right size image. The server could just serve it right away. There were some privacy concerns there because it's a fingerprinting. It's a way to fingerprint a device. So that hopefully that will come back once they've taken care of some of those privacy issues. So there are ways that the browser is working to tell the server what image to deliver.
So the decision is on client page. Without that headers.
Without the headers, the client, the browser is making the decision which one to download. Yes,
so there is
correct.
one, just to continue the story, there is one great book, very little book, called Responsive Images, with all explanation how you code the in the HTML, and then you have fallback into image tag if nothing works.
Right.
So you basically build media queries into the figure tag, and then inside that you put different media queries for different screen resolutions. That's basically.
You could also try to get the user agent, and there's the server side thingy. You can just get the user agent and see if the device is mobile. You can just use mobile image.
And that can be tricky because user agents are a mess. But it is another way, because user agents generally can tell you what kind of device it is, and then you can have a database and figure out how to deliver it. You can fake user agents, and I do it all the time for testing.
Yeah,
so.
bots and everything.
Then you're not the
I know,
user
yeah.
that you wanna serve the image, right?
Totally. So there are a lot of different ways you can do responsive images. But generally, the best way to do it is with the picture tag and media queries. And so you could also do it with some JavaScript. I mean, there's a number of different ways to attack that. So a year ago, 58% of the web was passing with responsive images, and it's still 58%. It hasn't changed year over year. 26% of the web are failing. Those pages would be a second and a half faster and save 130 kilobytes. The median page down here, this 8%, would again be 14 seconds faster and 2.4 megabytes saved data. I think a lot of these web pages are failing all four of them. And you fix one, you make a huge improvement, but if you fix all four, you'll make a great improvement. So those are the three tests for single images. The last one I'm going to talk about is lazy loading. And the idea behind lazy loading is if you have a mobile web page like this, only load the images that are going to be on the screen first. And don't load the ones that are below the screen, and then use JavaScript to have those images come in later. And there are a lot of blogs on how to do this. A year ago, 22% of the web was passing this. It's now 56% of the web. So there's been a lot of progress on this. These pages down here that are failing could be the median page would be 3 seconds faster. Down here, the median page would be 12 seconds faster just by doing lazy loading. We've seen this, and you've seen this like on web pages. If you search for cats in costume using a Google image search, you get these placeholder images. And you can actually see it's green for the cat that's an alligator, the cat that's got a bunny is pink, the princess cat is purple, right? The color, Google is finding the primary color of the cat's costume and serving you a single color SVG. And then when the image loads, the green goes away and you get the cat dressed up in costume. Facebook does this, Pinterest does this, Medium does this, lots of web pages are doing this because we've become used to seeing, we know that an image is going to come in here as a user. And it also means that the page doesn't reflow. So if you're scrolling and when an image pops in and all the text moves around on your phone and then you have to find where you were reading in the article, when you have a placeholder image, the whole page is laid out immediately. So there's a lot of benefits for doing it this way. And again, these SVG files are like 100 bytes each. So they're super small. It's not impacting the web page performance that much. There's a cool tool called Squib that actually is more of a textured SVG instead of just one color. You can sort of see the color of the waterfall there. So it's kind of a fun way to do it. This was like 900 bytes, zipped it's like 500 bytes, it's super small. So I built this web page that's super slow. It's like 15 megabytes because all the images are full size. And this is the desktop version zoomed out. So this is what you see when you load the page, and then you can scroll down and see all these different screens, right? There's different page views. And when this page loads in Chrome, first you get the text, and then you start seeing the placeholders come in, and you keep seeing the text reflowing, right? The text is sliding down as more and more images come in. But what's also interesting is if you look, like even here, that image right there is still the placeholder. But we have a picture of a cow and pictures of mountains, and all this stuff down here is loaded. As a user, you may not have scrolled yet, because you're still waiting for up here to load. Right? You don't, at least I don't necessarily scroll down unless I've seen everything at the top of the page. And you can see even here, like the cow is loaded here, but like there's still a gap. Like there's still things not loading. So the browser is just kind of loading things in a random order, and it doesn't make a lot of sense. Since Chrome 76, lazy loading is default on all web pages, and the browser will decide if it can lazy load. And what it does is it gets the dimensions of every single image. And so you can see here, the text doesn't move anymore, and it's laid out all of the placeholder images early on the web page. And what's great about this is now the browser knows the order of the images, so the images actually load from top to bottom, and the cow doesn't actually load until way down here, not early on. So it's actually loading the images the way you scroll through a web page, which makes sense. Yeah?
So what you're saying is that basically if you consider that your users are using the latest version of Chrome, you don't need to worry about lazy loading.
You don't, but not everybody uses Chrome.
Sure.
So there are JavaScript libraries that will implement this for you for all the other browsers. And then it turns it off for Chrome because Chrome is doing it automatically. So there's a JavaScript library that will do this for you as well.
Do you anticipate that in near future that every browser will adapt that?
So eventually, yes. I think for the next year or so, if you want to do this lazy loading for Safari and for Firefox, you're going to need to have the JavaScript library. I'm assuming that on Edge, once Edge comes out as a Chromium browser, this will come as part of that. So for modern browsers, yes. The great thing about the JavaScript library is it will work for old browsers too. Like it'll work for, how many people still have to worry about IE browsers in the stuff they're building? Yeah, there are a few hands. Like it still exists, and you can actually get lazy loading working on those IE browsers as well. So yes, if you just want to deal with Chrome, you can just let the browser do it on its own. But if you want other browsers,
But what about mobile?
this is in Chrome Mobile, I'm pretty sure. But obviously not mobile. But it wouldn't be Chrome on iOS because Chrome on iOS is based on Safari.
WebKit.
WebKit, yeah. So it's based on WebKit. So Android you're set, and Chrome desktop you're set, but everybody else you need to have a JavaScript library to do this. This doesn't make your web page necessarily load faster, but it makes it look like it's loading faster, right? Because here, it looks like the page still hasn't loaded. But here, it looks like the page has finished loading. You can start scrolling. So it's that perception of loading faster, which is really important for your end users. So that's what's in Lighthouse, but there's some other things we can do to speed up our web pages. Who loves animated GIFs? All right, everyone loves animated GIFs. And so when I lived in Seattle, we lived on a couple acres and we had goats. And so this is Nora, this was our goat. And I recorded a video of Nora on my phone, and it was 1.4 megabytes, and I'm like, GIF, yes, right? That's awesome. The problem with turning videos into GIFs is it got almost 300% larger. And so why is that? And so GIFs have been around for a long time. If you actually go back to 1990 and you read the spec for the GIF, it says the GIF format is not intended as a platform for animation, even though you can do it. And so, like, the people who made GIF said you shouldn't use animated GIFs. But like, we all use animated GIFs every single day. So what are we doing, and why is it so bad? Well, actually an animated GIF, if you have 30 frames per second, it's literally 30 GIFs that it's flipping through really, really quickly. There's no compression through the time frame, which is what video does. Video does compression through time. GIFs don't do that. And so what you should do is actually turn it into a movie. And GIF as a format is 256 colors. I stripped out the audio channel because A, listening to goats eat, not the most pleasant sound in the world, but also GIFs are silent. So if you strip out the audio channel, you've just made the file smaller. It's going to download faster. And as you can see, it's now 250K. It's 93% smaller than the original GIF. It's going to load a lot faster. Of course, that leads us to think about, like, but Twitter uses GIFs. If you can't see, like, it says GIF in the corner. But Twitter's lying. If you actually look in Chrome DevTools, they're serving movies. So it's like GIF the medium, not GIF the format. So you should always use a looping movie and not a GIF, because it's going to be way smaller. And if you look, that's 396 kilobytes instead of megabytes for that animated GIF. And so the way you do that is in the video tag, you make it loop, you make it autoplay, and even though it's silent, you have to tell it muted. And the reason for that is mobile Chrome and mobile Safari won't autoplay a movie unless it's muted. And the reason for that, I think, is Chrome engineers sit in meetings too. And like when you open up, when you're bored in the meeting and you open a web page and video's playing, then people know you're not paying attention. So video won't play unless it's muted. So this works, and you can do that, and that's what most web pages do now. That's what Slack is doing, that's what Facebook is doing, that's what Twitter is doing. They're always using videos. If you're really into this, you can actually serve in the picture tag. Safari will play a movie inside the picture tag. So in this case, you could have the looping movie, have a fallback to the animated WebP for Chrome, and then everybody else gets the animated GIF. And the reason you might want to do that is the movie loads in 4 seconds on a mobile connection, whereas the animated GIF takes 22 seconds to load on a mobile connection. Like, that's way faster, and you can't tell the difference. It looks exactly the same. Where's the goat? There's the goat. There's Nora. All right, anyway. A couple more things we can look at on how to speed up web pages. One is, what are our customers saying? And, whoa, I hit the wrong button. All right. Has anyone heard of light mode? It used to be called save data mode inside mobile Chrome. And if you go into your settings on your Android phone, if you use Android, there's this light mode, and you can turn this on. And it does two things. One is, if content is HTTP, it gets proxied through Google, and they'll optimize all the content and make it smaller. So you'll save data that way. But most content today is HTTPS, and that's good because HTTPS is more secure. So that won't actually make your files smaller. But what it adds is it adds a header. And that header is sent to every single web page, and it's saying, save data on. Basically, you're telling every single server, don't send me that much stuff. And so if the browser, if the server is looking for that, it can actually serve you a different web page based on what you're saying and serve you different content. iOS 13 has a low data mode, and I don't know what header it's sending. I haven't figured it out yet, but it also has a low data mode that says, hey, serve less content. I'm on a limited connection, or I'm roaming, or I just don't want all of that data. Yeah?
Is the previous one in some kind of standard, or it's kind of, it's just Google's?
I think it's just Google's thing. I don't know if it's really a standard. It's not an X header.
Yes,
If it begins X dash something, that's one that's not standardized. So the fact that it is saved data makes me think it may be standardized. I think it's only implemented in mobile Chrome right now. Because it's there, you can see this header and you can serve different content. Maybe reduce the number of images, maybe reduce the number of videos or something like that. I got the chance to go to Russia last year, and I was wondering how much it would cost to roam in Russia. And with my Irish SIM, it was going to be 10 euros a megabyte to roam, right? I didn't roam. Even with saved data on, it's not worth it. But if people don't want all of that data sent, if you see someone with saved data on, maybe you turn off the animated GIFs and just serve an image, or don't serve the movies, or reduce the number of images, or lower the quality of the images even more. And you can make your page load faster for those people as well. So Tim is based in Belgium, and he has a web page, and he found that 50% of his users have that header, and 10% of those have it turned on. So 5% of his customers were saying, send me less stuff. And so he actually built a second set of images, or he actually serves them a smaller version of the image, right? If you have responsive images, you can serve a smaller class of image to people who say, save data on. If they're asking for less data, we can serve that to them. We have the ability to do that, and so we can give them a better experience with honoring their request. And so Cloudinary will do that. If you save an image as QAuto and it sees the saved data, it will serve it as a QAuto eco, and that saves another 40, 45 kilobytes, just optimizing that image a little bit smaller. So there are actually websites out there that are doing this. It does lower the quality a little bit, right? In this case, it may be a visible change, but your customers are asking for that, so it may not be that big a deal. The other thing you can look at is the Network Info API. And so this is JavaScript, and the JavaScript will actually say, you can actually request, hey, what's the downlink speed of my network connection? And if the network speed is slow, maybe you serve different content. So that month I lived in West Cork, Ireland, my Airbnb said it had high-speed Wi-Fi. What they didn't say, it was connected to a 3G router that really only had 2G service, right? It was slow. It was really slow. And so if I was connected to 3G and I went to Facebook, there were no videos. There were no animated GIFs. Why? Because if the videos don't play, Facebook knows I'm going to get pissed off. And I probably won't come back to Facebook as much. So they remove them. And they serve different content. They're actually looking at my network speed and serving different content to users on slow connections. If I went into town where there was a tower and I had good speed, then all the videos and the animated GIFs and everything came back. But if you're looking and you see that your customer has a low speed, serve them different content. Hide the animated GIFs. Or maybe, like Twitter will actually put a play button on the GIF. So you have to press play for them to download the GIF and for it to play. So you don't waste that data and the page loads faster. So you can actually look to see how fast their connection is and serve different content. And that's pretty useful. Another thing I've seen websites do is base64 encode images. And so what that is it turns your image into text. And that's great. Like back in the day when you wanted to have fewer requests, that was good, but that doesn't matter anymore with HTTP2. What it ends up doing is it ends up blocking the rendering of the page. The images are bigger when you encode them as text. They're harder to cache. You can't reference them more than once. Like this is an anti-pattern now. You shouldn't do this. There's a university in Nebraska, in America, And there's a CSS template that's used on every single web page at this university. Every single department uses this template. They're sharing it across the whole university. It's 91 kilobytes, and 48 kilobytes is an SVG that's base 64 encoded. That SVG never appears on a single page at the entire university. It's like their logo with the Latin in the middle, right, and all that. And I was like, well, why doesn't it appear on any page? And I went to their style guide, and it says, departments, colleges, and other units should use the Nebraska N as their logo. Never use the university seal on any website. But it's being downloaded on every single website. Right? That's just wasteful, right? If they remove that SVG file from this file, it would be, what, like 40 kilobytes, 43 kilobytes. It would download twice as fast. That would make their web pages that much faster. But no, they're downloading that over and over and over again, and nobody's using it. It's just wasteful. This is another web page. You know how like web pages have like the star ratings, like there's 4 or 5 stars? They base 64 encoded a star 16 times. The other problem with base 64 encoding is it's gibberish and we can't tell what it reads. So this developer's like, did I put it in there? Paste. A day later, did I put it in there? I'll just put it in again. There's 16 times on this file. And you'll notice that in between, it's a similar spacing. That's the outline of a star, 16 times. So it's just this file is ginormous and it's got all these base 64 encoded images, just wasteful. It's just wasting data.
But if you gzip that, you will basically get it for free, more or less.
Not if you have the same image 16 times. You're basically downloading that same image 16 times.
Because it's in different tag, right?
Well, no, this text right here is literally the image.
Yes, but it's same text for each one.
It's the same text.
Yeah,
This,
and it will compress well.
so it does, because it's the same text over and over again, it does compress well, but if you only had it once,
Yeah, then
it would compress better than having it 16 times and compressing. So yes, you're right. If you compressed it, it would compress pretty well, but better only to have it once than to have it 16 times. Because
there's also an issue with older phones because they still have to process it.
Yeah, so the older phone still has to process all of this text before it can put it on the screen. And it is CSS, and so it has to process the CSS before the page can show up on the screen. So processing this file 16 times, maybe it doesn't hurt the download as much, but the processing, it's not super efficient. There are better ways to do this than this. So we can optimize image quality, format sizing, we can lazy load the images. Animated GIFs should be movies. You shouldn't base 64 encode images, and you can use headers to decide what content you're serving. And with all of that, here's the tools that I use: the web page test, the HTTP archive, Image Magic, structural similarity, lazy sizing, responsive breakpoints. Cloudinary is an awesome tool for doing all this on the fly, and images can be fast and beautiful. So with that, thank you so much. I'd be happy to take more questions as we continue the evening. Yes, go for it.
Do you have any data or study or something to comment out about lazy loading and how it affects the overall experience of the page compared to, charts that you showed us about just the loading?
Right. So
it's about perceiving. I know that
it perceives to be faster. The other thing is if you're loading only the images at the top of the screen, the whole page loads faster. So it does speed it up. The companies like Medium and Facebook and Google haven't published any studies for it, but the fact that they're all doing it and are still doing it sort of tells you that it's a good idea, right? If it was an experiment that failed for them, they would have turned off lazy loading and gone back to the old way. But I do believe it saves data. The other thing where it saves is if you look in your analytics, you may see that on mobile, people don't scroll all the way down to the bottom of the page anyway, right? They get to the content they need, and then they go on to somewhere else. And so if you only load half the images, right, you're not spending all of that bandwidth on your servers. And it also means the page loads that much faster, because if you don't load some of the images at the bottom, it's going to cause that page to load faster. So there are a lot of different reasons why you might want to do that. to do the lazy loading. From what I can tell is it does actually speed the load of the web page, because the way Google is doing it, and I'm gonna have to, it may just be faster for me to do it this way. The way Google is doing it is it's identifying how many images are below the fold, and it will load these first, and then once the page is loaded, it starts loading these in the background. So these all will eventually load, but it's loading from top to bottom, so it just makes that page load look faster.
I know another technique to achieve this, which is based basically on grid CSS pattern. Basically, you can avoid that jumping of the page when images are loading when you prepare the page for image height.
If you use the image height and width, you will avoid that bounce of the image as well. Yes, for sure.
Another way to do this is through CSS with grid. You know the grid.
Yeah, so there are a lot of different ways to prevent to make sure that the images that load don't cause the text to bounce around. What's great about doing the lazy loading is you also get the order of the images loading in order, whereas if you don't do that, you might get, where's my example? Other way. You might get images down here, right? What's great about the way Google's doing it now is, or with the JavaScript files that you use, is the images, you don't get these images loading way down at the bottom. As a customer, you don't know they're there, right? You get the images loading from top to bottom, which is the way we consume the content on the web anyway.
By the way, there is an article, or well, I should say case study, by the guy who actually invented the Google images, like the whole thing. I was trying to find, but I couldn't. I'll try to find, maybe I can share it with you guys, because it's literally like mind blown. Like he takes so many things in consideration, because there are so many randomness that can happen, and it's really just mind blowing. Because can you please go back to the Google images?
Oh, yeah, right.
So this is the thing, they don't know actually the height of the images. So they have to guess it. They have to, let's say you're looking for cats in
costumes.
Yes. So they're just guessing it. Like now the images is actually that height. And that's the beauty of it, right? Because when you look on the right, you see the pink one? Yeah, it's completely off. But to you, to the end user, it seems like it's the same one, right? And that's I would say that's the most powerful way to lazy load it. Yeah. But like, it's complicated. So.
I think it was invented in Flickr first. They had the masonry layout. Remember that?
Right.
Back in the day.
It's not as fast as this one.
Oh, sure, of course.
That's the thing, because they actually took the desktop as the base case, because it has the wider canvas, and that's actually the hardest part about it. So.
And as you can also see, like they're doing, like it's not a grid. Like if it was a grid, they'd all be in a box, right? They're all off center. Like it's really incredible. That article is incredible on how they build it. It's one of those, 30-minute read sort of blog posts on how they built it. Yeah.
I have a question for you. Have you ever done any psychology, like studies, with users about their expectations? Because not everyone knows that they can get the images faster, or like not everyone expects that. And sometimes I wonder if all this is like too much for our users sometimes. So
eventually, you may not need to do all of the optimizations I'm talking about when you build images. Like maybe you can get away with just responsive images and that's good enough. Or maybe responsive WebP images is enough. You should look to, all of this is extra work, right? And so, but if you implement, from what I've seen, is if you implement one or two of the, once you implement one, you're 50% of the way there. If you implement two, you're like 75% of the way there. And at some point you just have to say, too much more work, we've made a huge improvement. But from what I've seen is actually right now, like in the last month, Shopify automatically turns all images that you upload into WebP. And so we're actually going to have a case study in the next couple of weeks from Shopify because, you know, to be honest with you, do you remember all those screenshots? A lot of those were Shopify websites, right? So like they were serving these really bloated PNGs, and if all of a sudden they go to WebP, those web pages are going to go from like okay to like super fast. And if they see a huge jump in conversions, like that's sort of the case study I'm expecting to see out of that data. So from what I've seen, yes, there is a huge improvement. There are case studies out there where people have optimized their images and they see a huge jump in how people use their web page. And a lot of them are e-commerce sites. So like in the UK, like John Lewis is a giant department store chain, and they've got blog posts on how they've sped up images and it leads to people buying more things. Or, you know, the big thing that always happens is you always hear about the company that goes black the day after, in America, at Thanksgiving, right? Black Friday is the day everybody buys stuff in America. And so many people hit the web page that it goes down, right? If your images are too big, that can actually be one of the things that causes a load on your server. So if you can optimize those images, you're less likely to go down. Yeah.
Is progressive image loading completely dead? Or?
It is not. And there's actually a new format that they're working on. It's called Jpeg Xl, which is funny because you think of XL as being extra large, but it's not. It's actually smaller. And what it actually does is it does progressive loading with one image. So progressive loading, the idea is JPEGs have different layers, and there's like 8 layers. So it starts off like, you've probably seen it on a slow connection where it's all, it's pixely, and then it slowly gets sharper. That's what progressive loading of images are. Many web pages still do progressive loading. WebP cannot be progressively loaded because it's based on a video format. It's literally a 1-frame video, and so it loads top to bottom because that's the way video files load. But this new JPEG format is progressively loading, and then it does really neat things where you only need one image, and it'll actually deliver the right number of pixels for that size. So it'll actually do the interpolation. So if you have an image that's 1,000 pixels wide and the screen is only 100 pixels wide, it will serve every 10th pixel and give you a complete image on the small device. So it's the same image, you don't need a series of different images. That's coming, probably 2 or 3 years until it's in a browser.
I basically wanted to ask you that next question, like what is photo alternative to like Mpeg Dash and HLS for the video?
Okay.
Basically that is it, what you said.
So Mpeg Dash and HLS is streaming video.
Yeah, but they do that. You have one video file and the format basically does the
So you have when you do video streaming, you have 5 or 6 different video files on your server.
Yes, but on the client you just...
And the player in the browser says, "Huh, this is Doug's phone. He's on a crappy connection. We'll serve the smallest one so that it will play." Or this is Doug. He's in Belgrade. He's got a good connection. We'll serve him a medium quality one. Or wow, he's on his desktop on really fast Wi-Fi. We'll serve him the 4K version. So that's kind of what responsive images are today, right? It'll serve the right image for the size of your screen. That's sort of what streaming video does.
The thing is to have it like on the front end, you just have a video tag. You basically put the video tag. You don't need to do the checks and things like that.
So it does do the checks. The browser is doing those checks.
Browser, yes. You don't need to do the JavaScript tricks.
That's true. So when it comes to video, the best way to do it is with video streaming, if you can build the streams. I mean, that's how YouTube delivers all of its video. That's a whole other talk. And it could be a couple-hour discussion on the best way to deliver video. But yeah, and there's new image formats coming out, and there's new video streaming formats that are coming out as well that are going to save a lot of data with no drop in quality. So constantly evolving landscape, but right now for images, we're looking at WebP, we're looking at JPEGs. Jpeg XL is coming, but we don't need to worry about it for a long time. At least in production, we don't need to worry about it for a long time. Like they're working on it still. Yeah.
I'm not sure if you have used it before, but how do you feel about combining these things for enhancing the web performance on the website with the service workers?
With service workers, so a service worker, it means that you've got local storage on your device, right? So it's like a progressive web application. So if you have local storage on your device, I think that's great, right? Then the images are local. Just like if you have an image cache just in the browser, caching things locally, they're going to load a lot faster than downloading them over the internet. So caching is always a huge thing. There's just not time to get to everything in this talk. So if you don't have a service worker turning on your cache headers, right, if your logo is already local in the browser, it's going to show up immediately. If it's in a service worker and stored locally on the device, images, they're going to show up on the screen immediately because you only have to read in the memory of the device, not download them over the internet. So it's a lot faster. Yeah.
For the logo, especially because I'm speaking right now for very high, very heavy images. The logo, especially, if you want to use the storage, you can easily use the HTML5 local storage.
Yeah. Yeah, so storing those things locally is huge. When I was working at AT&T, I was helping Netflix speed up their application. And when you fire up Netflix, you get the red screen and then you see all of the movies that are playing. And 6 years ago on Android, they weren't caching those images. So you'd turn on the Android app and it would download 6 megabytes of images. And then you'd quit the app, start it up again, and it would download 6 megabytes of images. So it had the right headers to store those files locally, but it wasn't actually saving them. And so once they turned on that cache storage in their Android app, the load time went, they also did image optimization. So the initial load was 1.5 megabytes, but the second load was nothing because everything was local. It was tens of milliseconds over like tens of seconds. So having files local is a huge way, obviously, to save and to load things faster.
All right, guys. So I think we are done with the questions. So thank you, Doug, so much for
Thanks for
being
having me.
here. Thank you, guys. Applause for that.